Morning and welcome in the next video lecture of radar and TV engineering. Today we have the new topic of TV engineering, that is camera tubes and the picture tube. So these TV transmitter camera tubes and TV receiver picture tube is used to convert the image into the electrical signals, and then at the receiver the picture tube is also used to convert the electrical signal into the picture or image. So these are the basic fundamental of camera tubes and picture tube. TV transmitter camera tubes and TV receiver picture tube. These are the main content of this video lecture. To learn about the basic fundamental of the CCD cameras, to understand the basic concept of picture tube, students will also learn about the working of the picture tube and construction, working, and how the image is converted and picturized at picture tube. The outcomes of this video lecture is student will understand the concept of the CCD camera, understand the construction and working of CCD camera and advantages, disadvantages of CCD cameras. They will also learn the picture tube. Students will also learn a type of picture tube, which type of the picture tube is used in the TV receiver system. These are the textbook and references. The monochrome and the color television, second edition, RR Gulati 2015 US publications. Some references are also given here to understand the concept of TV system. Now come to the CCD camera. What is the CCD camera? In the previous lecture, we have already discussed the camera tubes, and now we have to discuss the CCD type of camera. In the previous lecture, we have discussed the Vidicon camera tube and the working principle and the advantages of the Lumbicon and other camera tubes. We have also discussed the types of the camera tube construction, working principles, and how the image is converted into the electrical signal through camera tubes. So these sensors are the operating on the principle of charge coupled devices. Here, a large number of the CCD array are formed together construct the image plate. E-type substrate, a thin layer of the silicon dioxide is formed, and by masking and etching process, an array of metal electrodes are formed. A large number of small metal oxide semiconductor capacitors are formed on the surface of the substrate. So, P-type silicon type substrate is used, and oxidation on the top of the substrate is formed by the silicon oxide, and by the application of the small positive potential at the gate, every third electron is connected to the common conductor. The charge transfer in the CCD device, how the charge is transferred into the CCD device. The spot under the each metal electrode serves as a light sensitive element. These electrons are collected in the potential valve and represent the optical image. The charge stored in one element is transfer to the next element by applying the more positive voltages to the next gate. CCD cameras, the horizontal shift registers, vertical shift registers, and sensor, and we have an output. The charge movement takes place like this. The charge is moved to the end, is collected to form the signal current. The one-dimensional array, as explained above, is used to represent one scanning line. These lines are independently addressed and output is read out using the address register and drive phases. So this is the photo sensor, or we have a vertical shift registers and the horizontal shift registers and amplifier. Through this diagram, you are able to understand the concept of how the image is developed in the CCD camera. The image is converted into the electrical signal. So photosensors are used here. Photosensor is a device which sends the light from the image and the brightness and colors and other signal from the source, or the photo from the object. So photosensors convert the image into the electrical signal by converting the photosensors is connected with the vertical shift registers, and the vertical shift register is also connected. All vertical shift registers shown here is connected with the horizontal shift register, and this complete output of shift register is given to the amplifier. So amplifier will produce the electrical signal. So this image is converted into the electrical signal. Now CCD image scanning, how the image is scanned to the CCD. The CCD image scanner consists of a large number of CCD devices arranged in the rows and the columns to form an image area. Individual lines are addressed sequentially using an address register. The output circuit will contain the electrical representation of picture information. It does not need an electron gun, become high voltage or vacuum envelope of conventional camera. For interlaced scanning in the cameras, the charge transfer to the vertical shift register is accomplished in two stages. The odd number rows followed by the even rows. Next, the charges in the vertical registers are shifted into the horizontal shift registers and clocked to the CCD output. All the odd rows are clocked out first, followed by the even rows, even feed. The rate at which the charge from the horizontal shift register is clocked out is governed by the number of the elements, that is the pixels per row and video standard the camera complies with. The main advantages of our CCD cameras is the high sensitivity, image lag absent, spectral response good, sensor withstand excessive illumination, no geometrical distortion or non-linearities, lightweight and low power. So these are the main advantages of CCD camera. It is very important to understand the concept of CCD cameras. Now, with these some advantages, we have some limitations or drawback of the CCD camera. So, requires the external processing unit. The CCD camera is required external processing unit to process the image into the electrical signal. Relatively high power consumption is required, and the expensive because of it is used the some sensors and registers, so that's why it is sometimes it is expensive. Now, the main application part of the CCD cameras, the barcode scanners, cam camcorders, and fax machine. So these are the main part of application that is used in the barcode scanners, camcorders, and the fax machine. Now we have a video processing of the camera pickup signal. The optical image is focused by the lens on the glass face of target plate. The optical image is focused by the lens on the glass plate of target plate. The lens regulates the light by the iris built into the lens housing, and the output of video signal is taken across the load resistance. So the image is converted into the electrical signal. The optical image is focused on the lens and the glass plate, and then it is producing the video signal, and which is taken to the across to the load resistors. So this is the principal diagram of the camera tubes, how the camera is developed the video signal. The light from the scene is focused on the lens, and the lens is produce the signal that is light signal, which is passed to the on a deflection is on a glass plate or target plate, and the cathode gun is produce the electron beam. So on the glass plate to target plate, so correspondingly electrical signal is developed, and Vidicon blanking Vidicon type of the our camera tube is generally used to produce the image into the electrical signal. So the output of the glass plate is provided to the load resistors, and we have a three amplifiers to amplify the output signal processor sync adder or synchronizing pulses is added by the sync adder, and the blanking pulses is added at the signal processor and the sync adder in between of the signal processor and the sync adders. So in the Vidicon camera tubes or camera tube, we have a magnetic deflection and the focusing coil. The arrangement of the deflection and the focusing coil is used to deflect the electron beams and maintain it at the center. And it's focusing the coil. So correspondingly, we will get the video signal output. Important box. How this video signal is developed. Amplifying the weak low voltage signal from the load resistance RL. Addition of the blanking pulses and the addition of the sync pulses. So the low weak signal low signal or weak signal is amplified by the amplifier, and we have a addition of blanking pulses and the addition of the sync pulses. The signal current or the voltage across the load resistance RL. So a pre-amplifier is used at this stage. So amplification is required at the stage of output of the camera tube. The output terminal of the camera tube is to avoid the external interference. In the second stage, we are using a signal processor to add a blanking rise during the horizontal and the vertical with trace intervals. Sync adder circuit is used to add the synchronizing pulses in the output of camera tube. The output waveform has a voltage of uh, 1 volt peak to peak across the 75 ohms as shown in the figure, that is the located at the some distance from the camera tubes. Now, principle of the working in the block diagram of color TV camera. Before discussing the color TV camera, we recall that the how the black and white TV camera is convert the image, optical image into the electrical signal. So, image is focused on the lens, and the lens pass the signal or image and collect the image, and is focused on the glass face plate, and the electron beams are focused on the glass plate, and they correspondingly the signal is developed, and this signal is again amplified, and sync and blanking pulses is added into the signal, and then this signal is developed at the load, and we have the signal. These signals are at the load resistance at the 1 volt peak to peak at the 75 ohm resistance. So we have to develop the signal at the output of camera tube. So now we have the color camera tubes is used to split the optical image into the primary colors. And these primary colors are the red, green, blue. The special type of the mirror called dichromatic mirror is used. This is the diagram how the light from the picture is come, and this picture is light is converted into the three primary colors, that is the red, green, and blue. So a special type of the mirror is used, that is the dichromatic mirrors, which splits the light, and it converted into the three primary colors. So here we have a lens assembly and light source from the picture, the color conversion and the natural density filters, and relay lens, and we have a red, green, blue, three type of the voltages is developed at the output of the dichromatic mirrors. So we have some relay lens which producing the relay in the light densities, and M1, M2 are the some dichromatic mirrors. So we have the output of the relay line, that is the red camera, green camera, and blue camera. So three primary colors is developed at the output of the light source. That is the red dichromic mirror reflect the red colors, and all other color to pass through it. The scene is focused by the zoom lens package on the dichromic mirror setup, and they are passed through the color filters. These filters can provide precise primary color images. Each camera tube develops a video signal voltage proportional to the color intensity received by it. A video preamplifier amplifies the VR, VB, VZ, red, green, and blue signals. In the output stage, a resistance network is used to generate the luminous Y signal and color signal. The resistance values are so related such that the Y equal to the 0.3 R plus 0.59 Z plus 0.11 B. So this is the equation for the luminous signal, that is the Y, and color signal. If only red color light is focused, then we have only the red camera output VR. Then it will comes 30 upon 30 plus 70 into VR, that is 0.3 VR. Now we have after discussion the camera tube. Next the tube is the picture tube. Picture tube is used at the receiver, and again I am explaining that the picture tube is a tube which convert the image for electrical voltage into the image. Now specifications: the size of the picture tube is general denotes the diagonal length. The size of the picture tube ranges from about 1 to the 30 or more. So the size of the picture tubes is ranges from 1 inches to the 30 inches or more. Most of the commonly used tubes in the black and white TV and color TV are 51 centimeter and 36 centimeter screen size. The tube 500 AM-P4 has a diagonal length of 500 millimeters. The last alphabet P specifies the screen phosphorus. So picture tube is having the range from 1 inches to 30 inch in the black and white color television system. And the case of the color television system is having the size of 51 centimeter to the 36 centimeter screen size. The monochrome picture tube specifications: the commonly used picture tubes manufactured in India and marketed by the Bharat Electronics Limited are 310 C1P4, 470 C1P4, 6110 C1P4, 590 CP4 picture tube. Employs the electrostatic focusing and electromagnetic deflection system. So all picture tubes are based on the principle of electrostatic focusing and electromagnetic deflection. Means the electron beam is focusing to the target or our screen, phosphorus screen, and the electromagnetic deflection is used to maintain the horizontal and vertical deflection of electron beams. In the next section, we have the construction working principle of the monochrome picture tubes. The picture tube is used to convert the video signal into the optical signals. The construction of the picture tubes is the main parts: electron gun, focusing anode, deflection coils, final anode, phosphor screen, and external conductive coating. So these are the main part of the our monochrome color picture tubes. In the next section, we have to discuss the one by one. So first, we have to discuss. This is the principal diagram of a picture tube. Here we have a cathode, and cathode is produce the electron beams by there is the electrostatic focusing and reflection coils to maintain this electron beam to at the center, and this beam is focused on the screen of phosphorus coating, and inner side of this phosphorus coating we have a aluminizing coating, and outer side of this phosphorus coating is having a glass face plate. So signal is applied, received signal is applied to the cathode, and this cathode generate the electron beams. So control grid, and we have a accelerating anodes and focusing anodes and centering magnets and inclusion error magnets. So we have a G1, G2, G3, three grids in the neck of picture tube. This complete arrangement is enveloped in the glass envelopes. Electron gun. The electron gun unit consists of the cathode, control grid, and the accelerating anode. It is the indirectly heated by a filament thorium, tungsten, or borium, and the strontium oxides are having the low work function and so release a sufficient number electrons of when heated. The control grid is used to control the flow of the electrons from cathode. It is also in the form of the cylinder and for flow of the electrons. The sprint grid is the maintained at the 400 volt, and focusing grid is maintained at 600 volt. To the base pin, only the rated voltage for different grids are supplied. Focusing anode, the electrostatic method is used to focus the electron beams. The positive potential at the accelerating anode is extended. This is the considered as the first lance action. Screen grid and focus grid forms the second lance system. The focus anode is larger in the diameter, and also its potential is the higher than the first anode. The voltages given to the grid are so selected that second convergence point is on the screen picture tube. The electromagnetic system is used to deflect the electron beams in the horizontal and the vertical directions. The picture tube produces the horizontal deflection, and another pair of the coil plays left, and the right produces the vertical deflection. Two pairs of coil are collectively called as a deflection yoke. In deflection yoke, centering magnet and in fusions magnet are also provided for centering electron beams. So the deflection yoke and the magnet both are used to focusing the electron beam to the screen at the moment of the electron beams at the corners. Final anode to provide the sufficient velocity and energy for electron beam. A final anode is included in the tube. This aqueduct coating is provided with a high voltage of the 10 kilovolt or more. The second electrons emitted from the screen are attracted by these coating. Phosphor aqueduct screen. The phosphor chemicals are light metals such as the zinc and cadmium in the form of sulfate, sulfide, and phosphor compounds. The atoms, while hitting spot fluorescence, emit the light. External conductive coating. The aqueduct is also coated on the outer surface of the glass valve. A spring clip used to connect this coating with the chassis ground. AC ripples in the high voltage and provide a perfect higher voltage. Working principle, an AC supply of 6.3 volt is given to the heater filament. This filament heats the cathode and cathode emits the electron. Hence, we applied the 6.3 volt to the heater element. This element, that is the cathode, emits the electron beams. The number of the electrons in the beam is controlled by the controlling devices. The accelerating anode increase the velocity of the moving electrons. It point and strike the phosphor coating on screen. The aqueduct coating inside the tube is given a high voltage in order of 15 kilovolt. Because of the deflection coil current, the beam is deflected both in the horizontal and vertical direction. The useful video signal is given to the cathode or control grid. It's called contrast control and brightness control. So in the picture tube, we have two types of the control. This control is used in the control grid or in the cathode, that is contrast control and brightness control. Due to the persistence of the vision of eye, the viewer accumulates all the picture elements as a whole picture. Now, phosphor screen, the phosphor chemicals are light metals such as the zinc and cadmium in the form of sulfate. So, this is the phosphor screen, which is used to in the picture tubes, and the material is used with zinc and cadmium in the form of sulfate. The kinetic energy of the moving electrons in the beam are transformed to the atoms in the phosphor coating. External conductive coating is also outer the surface of glass back. Decay time of phosphorus used in the picture tube is approximately 5 milliseconds in the monochrome picture tube. Screen bond. It is the defect in the picture tube due to the electrons, but the EHT voltage is present for long time. Because of the absence of the deflection field, the electrons continue to strike. This defect can be overcome. Next is the screen, aluminized screen. A very thin coating of aluminum is provided on the back surface of screen passport or all modern picture tube. The aluminum coating is connected to the high voltage anode coating. Aluminum coating reflects the light from the screen. Types of the color picture tubes. We have three types of the color picture tubes. Delta gun picture tube. This is an inline or gun inline picture tube. Trinitron picture tube. Three types of the picture tubes are, and the screen of color picture tube is coated with the three different color passport. However, the three color passport are separated from each other physically. These are the types of the color picture tube. In the next lecture, we will discuss about the detail of each type of the picture tube. The screen of the color picture tube is coated with three different color passport. In the case of the color TV picture tube, instead of using a single passport material. However, the three color passport are separated from each other physically. So this is the about the color TV picture tubes. And before that, we have discussed the basic principle and construction working of uh, the monochrome picture tubes. In the next lecture, we will discuss or will continue with the color picture tubes in detail. Now, in the next section, we have some multiple choice questions. First, multiple choice question number one. Which type of the amplifiers are used in the high level transmitter? A, class C amplifier, B, class A amplifier, C, number of no amplifier used, and D, none of the above. In the amplification of transmitter section, we generally use high level transmitter, which is known as power amplifier. In digital TV, EDC conversion is done by A, PCM, B, DPCM, C, DM, D, ADM. Multiple choice question number third. In a TV receiver set, sound and video signals are separated at the A, video detector, B, video amplifier, C, sync separator, D, IF stage. Question number four, the three primary colors in the chrominance signal of a color TV are A, red, green, orange, B, red, green, blue, C, blue, green, magenta, D, yellow, green, cyan. So three primary colors we have discussed that at the starting of transmitter section we have a dichromic mirror. This is the special type of mirror which split the three signal from the light. Question number fifth, a television system having a n is equal to the 525 and t equal to the 25 frames per second has a horizontal sync frequency of 50, a is equal to the 50, b equal to the 625, and c equal to the 625, and d equal to the 525. So these are the based on the NTSC system. Number 6, the signal sent by the TV transmitter to ensure the correct scanning in the receiver are called A. Sync, B. Chrome, C. Luminous, and D. Video. In the transmitter and receiver section, correct scanning is done by which concept? Question number 7, the interlacing is used in the TV frames to A. Produce the illusion of the motions, B. Ensure the scanning of all lines, C. Avoid the flickers, D. Avoid the humming. The separation of the sound in the picture carriers in our TV system is in megahertz. A. 5.5 megahertz, B. 4.5, C. 6, and D. 5. Equalizing pulses in TV are sent during A. Horizontal blanking, B. Vertical blanking, C. Horizontal retrace, and D. flickering. If a normal line sync pulse width is 4.78, width of equalizing pulse is 8, A. 4.6, B. 2.3, C. 9.2, and D. 1.5. So the today's video lecture is concluded as that we have discussed the camera tubes and the picture tubes. In the starting, we have discussed special type of the camera tube, that is the CCD camera. And, this type of the camera tube is especially used to scan the barcodes at the malls and the shopkeepers, libraries, and it has some advantages with some limitations. So in this, we have discussed the construction working of CCD camera. After that, we have discussed the picture tubes, how the picture tube is constructed in the monochrome TV system, and how the video signal is processed into picture tubes. And the video signal is picturized at the picture tube in the case of the monochrome TV system. In the monochrome TV system, we have discussed the picture tubes and the construction, working, and principle. A part of the picture tube, we have also discussed the color TV picture tubes and how the color is developed from the image, and how the 3 voltage is constituted in the TV system, and dichromatic mirror is generally used to develop the 3 voltages of colors of primary color. So these are the conclusion of today's lecture, and after that we have discussed the some multiple choice questions.